So you probably have heard of our story, our approach to microservices, and it's slightly different than your typical approach to microservices, which is quite often a direct strategy of a certain idea or a certain concept that you have, and you design your microservices, you design the interactions, and you basically start deploying them. Well, those types of projects are very hard. Microservices definitely are not easy. There's a lot of technical challenges, but more importantly, there's a lot of design challenges related to the domains, the domain-driven design challenges. I would call them. So quite often, these projects they diverge into creating a distributed monolith, or as some call it, or the way I prefer to call it, a distributed big ball of mud. And it's almost inevitable if you start a microservices project from scratch. The approach that we stimulate much more is an approach where you start off building a monolith, and as time progresses and as your non-functionals change, your non-functional requirements change, you can start splitting out certain components and start deploying them separately. Of course, as soon as you do that, you have certain aspects to take into account, mainly cross VM messaging, which is not very easy to do. It's possible, but there's always these little issues that you did not have in the monolithic approach that you now do have, and you need to take care of those. And as time progresses further, you can extract more components as you evolve. And in certain cases, you'll find that some components will never be extracted out of the monolith that they were originally in because they don't need to be, right? So probably originally in your original microservices approach, or in the Big Bang microservices approach, you could say, you would probably design those as different components. But if you don't really need to extract them, it's time gained. Now, the whole thing that makes this evolution possible is a concept that we call location transparency. And location transparency is a crucial element that Axon provides. And it is the concept that two components that communicate should not be aware of their respective locations. And that doesn't just mean that a component should not know what kind of protocols it needs to use to communicate with another, or whether the other component is deployed in the same VM or in a different VM. It's not just that. It's also which other components are maybe deployed together or separately. So if you look at most of the HTTP-based microservices that use service discovery, you know that you need to call a certain service. You may not know where that service is, but still you know that a certain call or a certain address or endpoint lives in a specific service. So that means that if you have multiple endpoints or multiple calls in that service, your component is aware of the fact that all these calls are in the same service, which is not exactly, which is not full location transparency. It's a good way, but we're not there quite yet. Another one, of course, is make sure you use proper APIs. Because quite often, if an API, for example, has a return value, the caller may assume that the return value is available immediately. In a distributed system, that is an assumption you definitely cannot make. So that's very important as well. So it starts with good API design. It doesn't end there, and there's much more to it. Now, Axon achieves this by using messages very explicitly in all of Axon, and that was already in Axon 1. That was the case for especially commands and events. And in Axon 3, we explicitly added queries there as well. That's not going to change in 4. But using these messages is a crucial element in achieving this location transparency. And we separate these messages into 3 categories. One is commands, the other events, and the other queries, because they follow very different patterns of messaging or patterns of routing than the others. So if you look at commands, for example, a command is typically routed to a single handler. We can use consistent hashing to make sure that multiple commands for the same entity, if you will, are always routed to the same machine as long as the deployment of machines doesn't change, right? Commands typically also provide a result, right? There's a very small message coming back with basically an okay or a not okay. Events are slightly different. Events are not sent to a single destination. In fact, the sender doesn't even know the destination of an event. They're just published. And all the logical handlers that are interested in receiving that event will receive one copy of that event. If a logical handler is deployed in multiple instances, so if you have basically multiple instances of the same service, one of these services will receive an event. And of course, their consumer should express the ordering requirements that they have. So they should be able to say, I am interested in handling events of the same purchase order or purchase. And so I want to receive them in order. So the event consumer then receives the event in the order they were published. Now, of course, there's a lot of events that can be handled simultaneously, right? Events relating to different purchases. I'm using the word purchases to avoid overloading the term order here. So events of different purchases may be routed to different machines because the ordering doesn't matter anyway. Events do not provide results, so they're really for the sender. They're fire and forget. And then the last one is queries. That's the new kid on the block, I would say, although the queries have been around for a while now. And queries are a bit of a mix of both. We support 3 different types of queries. The one is point-to-point, where you basically have a query for, let's say, an authoritative answer, right? There's one true answer, you just want to have it. So you can send a query, that query is routed to one destination, and that one destination gives you the answer, and that's it. So basically, you can use some form of load balancing in Axon Server, as we'll discuss later. It has a slight preference for the server that responds the fastest. But there's different routing strategies that you can use there. You can also use scatter-gather queries, and those are really useful for answers that should be interpreted as an opinion of a certain component. So, for example, the price of a product, you can do different calculations of the price of a product. There might be a default list price. There might be certain discounts. There might be discounts based on previous purchases, etc. You can do all sorts of calculations, and then you can do a scatter-gather query, which allows components to each send their response, and now you, as a sender of the query, you combine those responses into whatever answer you would like to use. And the last one is a subscription query, where you send a query and then you basically keep that connection open for updates. So as soon as the answer to your question has changed, you receive an update of that answer. So those are sort of the messaging patterns, and we have found that it's very important to distinguish between all of these 3 messages and not go all in on events, for example, which is a very unfortunately common pattern that we see a lot right now. Modeling everything as events does not help build disentangled systems. So if we look at our structured monolith, and we start off with this simple deployment, we can use Axon to have these components communicate. Axon framework works within a JVM, and every component in here that publishes a message will have that message routed to the correct destination by Axon framework itself. This is the way Axon has been working since 0.1 probably. Things are slightly different as soon as you scale out. So when you scale out, there's a number of options, and the most common option is to find existing routing mechanisms and communication mechanisms, and use those for the communication. So for one, you would probably want to use a shared event store for the two, because that's what they also had previously before the split. And you can then use the embedded event store to store events there and to read them as well. You can also use tracking processors, and then nodes would be able to read each other's events. It is somewhat of an integration through a database, but it's not as bad as other tables, but still. Now, for the discovery, there's multiple options. There was JGroups, and we also supported Spring Cloud Discovery. So let's say we want to use Spring Cloud Netflix here, which uses Eureka Discovery Server. Then we would have to configure a distributed command bus that uses that discovery server to discover other nodes and then communicate with each other, send the commands across using HTTP. Now, even though we could send the events through the event store, in practice, we've seen a lot of RabbitMQ installations as well to pass events from one node to another. And RabbitMQ works with exchanges and queues. And the exchange is really where you should publish your events. So every event bus or event store should have a connector or a publisher that publishes all these events to RabbitMQ. And to make sure that every node receives its own copy of every event, every application must have at least one queue from which it can read back the events and publish them to their internal components. Now, as you can see, this diagram is already getting a bit messy, and in the end, it's not really about how a diagram looks, but in practice, we also see that the configuration starts looking like this as well. It is fairly complex to find out how the messages are correctly routed, and if something is wrong, to try to find the place where this routing goes wrong is not trivial. And if we then start extracting more components, things really get worse. So well, the command bus is probably already works. You just point it to the existing discovery server. You would have to connect that to the same event store as well. And then you need to add an extra queue to make sure that the events are also routed, a copy of the events are also routed to the new service instance. And to make this a lot simpler, we have built Axon Hub and Axon DB, and we launched those Axon DB at the beginning of the year and Hub a little bit later. And they made it really easy for this communication to happen, right? A node would just, Axon would just connect to Axon Hub. Axon Framework would just connect to Axon Hub. Axon Hub knows about the difference between commands and events and queries and the way that they are routed to their destinations. And if you would then extract a new component, it would basically just tell the other component to also connect to that same hub instance, and then you're done. That's the only configuration you would need to do. And Axon DB would then take care of the persistence of all those events. And even when we scale an application up, so now the component on the left is scaled out, there's multiple instances, you can do that transparently, and that was zero configuration essentially. The only real configuration you needed to do is the position or the URL of Axon Hub. So why are we changing anything? Because we are changing something in Axon 4 about how this all is working. So we noticed that in the beginning of a project, you do not have the either budget or confidence or time to explore closed source services. So many of us, they combine open source because they are readily available. They're easy to access, right? You don't have to go through sales agents and managers and etc. to just start using something. So people start combining their own solution using these open source tools that are out there. And Of course, another option is to start with the closed source approach and start using with Hub and DB. And we've fortunately we have quite a few customers that have done that have made that decision to go there. And the feedback we got from them is basically that they all forgot about the fact that they had Axon Hub and Axon DB, because it makes them so much more. It makes it so much more transparent, right? They've indicated they could focus much more on that business logic, and that's exactly what we want. But in the meantime, we've also noticed that the transition of open source tools to Axon DB and Hub, when configuration becomes too complex to manage, that is somewhat of a step as well. So we've noticed that undeveloping all those custom built components and going back to Hub and DB is not as trivial as we wanted it to be. So we went back to the drawing board basically and decided, okay, what can we do to make sure that this advantage, this very smooth and elegant evolution can start from right in the beginning, instead of having to go through purchasing orders, etc. And one of the challenges we had with Hub and DB is that really you needed the combination of Hub and DB to get this evolutionary microservices approach, right? This location transparency was really achieved by the combination of the two. So we had to have a few discussions. Okay, what's Hub's role? Do we need Hub and DB together? Or somebody said, yeah, I just like Hub, because I want the messaging. Well, yeah, but it needs DB to run. So it was a bit of an awkward discussion every now and then. That's one. And the other one was, of course, the separation of the open source and commercial. So to make that simpler, what we have done is we have combined Axon Hub and Axon DB into what we now call Axon Server. But just that combination, just doing the combination of the two products in one, that did not fully solve or address the problem. What is also very important is that we have decided to open source a large part of the Axon server, so that you can start with an open source version from day one in your project. So as you can basically use the Axon Hub and Axon DB functionality in your product, unlike Axon DB and Axon Hub initially, without any limitations, right? There's no limitations on how much data you can process or anything like that. Of course, there are certain features that are only available in the commercial edition that are not available in the open source edition. And on the commercial side, we now have Axon Server Enterprise, and Axon Server Enterprise comes with a number of packs. So Axon Server Enterprise itself has some additional features, but we've also noticed that different deployments have different requirements of, let's say, certain features that they would like that are maybe not for the general public, so to say. So the scale pack, for example, is useful if you have systems that are distributed across the data centers globally. The big data one is if you have massive volumes of events that you need to process, and the security and compliance are for those companies that have very high regulatory requirements on how data is handled, to ensure that data is immutable or is stored safely on disk. And this new structure is what we have called Axon 4. So Axon 4 is really the main new thing in Axon 4 is the separation of server into the open source part, which of course combines very nicely with Axon Framework, with a possibility to take the commercial version if you need the additional features. So what you can now do is, instead of Axon Hub and DB, you essentially install Axon Server. Functionality-wise, it's very similar to Axon DB and Hub as they were before, except that there's no configuration anymore required to make storage work, for example. So you can just start an Axon server instance, and that's all you need to do. You can then connect your Axon nodes to that server. So some of the changes that we've made in 4. So Axon Framework 4 will default to using Axon Server. You can still exclude the dependency or make sure that the Axon Server connector jar is not available on your class path. In that case, it will fall back to the versions, the options that it had before. For example, the embedded event store with JPA, or the distributed command bus with Spring Cloud and RabbitMQ and everything that you had. So in the transition from Axon 3 to Axon 4, if you exclude the Axon server from the dependencies, you will automatically fall back to the former defaults. But that also means if you do want to use Axon server, and trust me, you do, then you don't need to do anything. It will just default to that to those settings, and if you don't do anything, it will look for the Axon server on the local host. So for developers, it's really quick to get started. And of course, you do need to specify an Axon server location if you're deploying to production. Now, another thing that we did is we simplified the configuration, and especially the configuration of event handlers and event processors. So we did an attempt in Axon 3, separating event processing configuration with event handling configuration, and basically the feedback was not mild. That was not an improvement. So we sort of reverted that change in Axon 4. But we have also combined, for example, the Saga configuration in there. So now it's much easier to create a single processor that handles events both for regular event handlers and Sagas, even within the same transaction, if you wish so. So that configuration is now a lot simpler. We did a number of API improvements so that we can support certain features that we had planned. There was a lot of feature requests for the Axon 3 branch that we really could not fit in the design of APIs that we had there. So we made some API changes in Axon 4. Nothing dramatic. Most likely, if you migrate your application, besides having to fix some import statements, you would not have to do a lot. And another thing we changed as well is we restructured the modules. So Axon 3 had an Axon core module that was actually pretty big because it contained, well, the whole of Axon basically, and there was some problems, especially in when using Axon in JE. There were some classes really in the way, so you had to exclude those. And now we have restructured these modules. We have an Axon messaging module, which contains the core messaging components like the command bus, event bus, and query bus, as well as the messages and all the annotations that come with it to be able to define your command handlers, event handlers, and query handlers. That module is in itself useful, especially for other frameworks. There's other libraries and frameworks using Axon's APIs to do messaging, and they could use that module as a standalone component now. Then there's the Axon modeling component module that helps you build aggregates and sagas. It contains the logic for aggregates and sagas and defining those. And the last one is the event sourcing module that adds event sourcing capabilities to your models as well. And that's where you'll find the event store, for example. The other modules have remained mostly intact. So the core modules, as I said, they are messaging, modeling, and event sourcing. There's still the configuration API, and there's still the Spring Boot starter in there as well as the test module that you could use to build the give and when then test. And then we have some extensions to the Axon framework, and those extensions have also moved to another repository. Right? They have moved to different repositories so that the build of Axon framework itself is faster, which is very useful for people that submit pull requests, they would like to see whether their pull request builds. And if you have a very complex build to run before you can see if your changes actually work, that's really annoying. So anything that's not impacted by any of your changes is now doesn't have to be built. And those extensions are essentially the components for Mongo. So the Mongo event store has now been moved to an extension. Kafka integration has moved to an extension. MQP, that is the support for publishing events to, for example, RabbitMQ. Then there's a Spring Cloud distributed command bus that has moved to a separate extension. And the last one is the JGroups distributed command bus. Now the group ID for those, the Maven group ID for those extensions has also changed. They are now org Axon Framework extensions dot Mongo, Kafka, MQP, Spring Cloud, or JGroups. And the reason we did that was because the version numbers of those extensions might differ slightly from the Axon core version. So the release cycle, if there's a bug in one of these extensions, we would just want to release the extension and not have to release the entire framework as a new version, because it probably causes a lot of extra downloads for people that they don't have any changes anyway. So if we look at Axon Server and Axon Server Enterprise and all the features that they provide, Axon Server is basically that's the core messaging component, messaging and storage component. So it takes care of the efficient message routing, so taking into account that events, commands, and queries are all routed differently. It does not have any knowledge of the content. So this is not an ESB. ESBs typically have knowledge about the contents of a message. Axon Server does not. We very deliberately do not look into messages. Then there's the storage, of course, that it does file system based, reasonably fast. And then there's a basic application monitoring. I'll show a demo later on. There's support for SSL or TLS. And you can do manual event processor balancing. And that is something new that Axon Server will make sure that when there's multiple nodes reading events, that they all receive a balanced proportion of those events. So there's not one node, the node that started up first takes all of the segments for itself, and then the second one that starts has nothing. Right? Axon Server can detect that, and you can tell Axon Server to ask the nodes to rebalance their processing. Now, the enterprise version of Axon Server will support clustering, so you can build a large cluster of Axon Server nodes. It will have, it has more advanced monitoring capabilities. You can use app authentication and access control, so every application can have a token that can then be revoked, or you can create new tokens, etc. It can also do automatic event processor scaling and balancing. So not only the balancing is automatic, but it will also see, oh, a new node that can handle events has started, but there's no segments left for it. So it can auto scale the number of segments up and down as well to ensure that all nodes are actively processing messages. And the last one is multi-context. This is very important if you have large-scale deployments where not every event should go to potentially go to every other application. So you can create a context, and basically communication within a context is isolated from the other contexts. So you can compare it a bit to how a database management system has multiple logical databases in the same system, right? You have rights to read from or to read and write to a specific database, but not the other databases. And then there's the packs. The scale pack, as I said, is for worldwide deployments. So there's some location awareness in there. It knows about the location of servers and as well as applications, and optimizes routing based on those locations. It has readable replicas, for example, so you can read from a replica that is nearby so you don't have to get you don't have to track your events from the other side of the world. It has multi-data center support, so we take care, for example, of the fact that if you commit some events to the event store, you might have some specific rules. So I want a majority of my local cluster to have acknowledged the message, but I want at a minimum one outside of that location to also acknowledge the message before I consider that transaction complete. So you can have those kinds of rules. The big data pack supports sharding, so you can basically write a lot faster. You can have multi-tier storage, so you can offload older events to cheaper storage. Again, readable replicas, because, well, if you have a lot of data, you have to be able to read it fast. But you can also have these quality of service messages. So you can have a specific level of priority to messages, so that if you have a large batch process, for example, that the interactive messages are given priority because there's a user waiting. The batch can slow down a bit so that users can actually get their messages processed faster. And then there's the security and compliance pack, where we have the privacy guard, formerly known as the GDPR module. We support encryption of data at rest. There's a possibility to do automated backups, and we have more advanced data migration tools. So quite often the data of those systems need to be migrated to specific types of storage at real time rather than as a backup. So how can you get to Axon 4? So if you look at framework, and Axon framework was and still is on GitHub. It will remain Apache 2 licensed, so then nothing much changed. You can use Maven or Gradle or whatever build tool you would like to use and get the artifacts from Maven Central. Now, when it comes to Axon Server, we are in the process of open sourcing or publishing the code onto a public GitHub repository. That is not quite finished yet because we need to disentangle it completely from the enterprise code base. We published the Axon Server on Docker Hub, I have to say, and you can also download them as a zip file from our website. And of course, for the Axon Server Enterprise, that is not something you can just get. You cannot. It's proprietary commercial code, so that's closed source. And you can contact our sales to get a copy of the enterprise version of Axon Server. We will also publish that through Docker, mainly as a convenience to our customer, but of course that is a private Docker repository where you can get those, and there's also a download server where you can get your copy. But by far the easiest way to get started, we've created a convenience package, a quick start package that contains Axon Server, Axon framework itself as well, just in case you don't want to use Maven to get it. There's a sample application, which is the gift card application that we have been using in demos every now and then. And there's a nice guide that you can just follow and step by step execute what's in there. And you can literally get started in minutes. You just go to axonit.io/download and get your copy from there. So I've been talking for a while, and maybe we should let the code speak for itself. That's the wrong project. So let's open the gift card project. So this is the gift card application, and it's a fairly small application that has a few packages. It has an API that defines our commands and events, and we have some queries as well. So these are the messages that we want to be able to send from one node to another. And then we have the command side, or the command component, so to say. There's a bit of configuration here. There's a repository, and the reason we want to customize that configuration is so that we can use a cache. Strictly speaking, you do not need this configuration to get it working. You can remove this; it will still work. But this was an example of how to use a cache inside a repository instead of using the defaults. And then we have the gift card aggregate itself that contains the business logic. Right. So really, this is all that we need to get a command handling component up and running. This is in fact the only class we really need to get it working. Now on the UI, there's a few more classes, and this has to do with the Vaadin UI that we've chosen, not because we believe it's the best type of UI to build, but it's we're techies and we want this not to be completely distracting. So we do have a data provider here that actually connects to our query gateway, and it uses some async mechanisms towards the UI, and that's why there's an executor service here as well. And then there's the query component that defines our projection. So this is the place where we receive our events. We have our event handler methods here. So when a card is issued, we persist a specific view model, and we also emit an update. And this is the subscription query feature that we have. So we can say that we want to emit an update to every component that did a count card summaries query. If the query meets these requirements, I want to send them an update of the count changed. And this is something we use for Vaadin to get real-time updates in the UI. And then we also have the query handlers here, which says, well, if I want to count the cards, I get a count card summary response there as a response. And then there's the app itself, which is a fairly simple and straightforward run this application. So let's run it. Let's see what happens. A few Java 9 related warnings. You can usually ignore those. And now it's trying to connect to Axon Server, and it is connected. Yes. So I have Axon Server running in the background right now. I installed the Docker image, and when you restart your machine, of course, that also restarts Axon Server. So now we can go to our UI, and we see this UI running. So we can issue a card saying card ID 1 for the amount of 123, and we see this. Now this is all, of course, in a single node. Even though it's communicating to Axon Server, there's a bit of an overkill on our configuration right now. So we can start a new copy of our GC app, and I'm going to clone this, and I'm going to call this command. Now we can use profiles to only activate the command side of this application. So I can now, I should be able to run this now. There we go. And now we should still be able to issue, let's say, 20 cards for the amount of 321. There we go. So it's been issuing a number of commands. Now I can also go to the Axon Server UI. So this is our dashboard. You can see I'm running the standard edition right now. There's a number of events. There's a few subscription queries active too, because I don't know why. Probably because the UI wants to subscription queries. And I have an overview of my application. And right now I can see that there's two applications running. The application name that we've chosen in this application is GC for gift card dash, and then all the names of the profiles that are active. So we can see this application is running command, query, and GUI, whereas the other application is only running command. And we can open that, and we can see that there's a number of commands that it supports: the issue, redeem, and cancel. Whereas this one has much more. So this one has the commands. It also supports certain queries. There's a number of subscriptions that have happened. There's a few still active. And here we see the tracking processor. So there's one tracking processor active. There's a rebalance button that we can use just in case we have multiple threads active, but they're not nicely balanced on the different nodes. We can see the commands. We can see how they are routed. So this is part of our basic statistics. We will have slightly more advanced features also in Axon Server Standard Edition in future versions. But now you can see that 12 of the issue commands have routed to the command, query, and GUI component because it has been running for longer, and then the 9 others to the just the command application. Now, if I were to stop the GUI application and relaunch it using query and GUI, so I'm leaving command out of it right now. So my overview, you can see that the application is now gone. And now my other application is up. I should be able to refresh the page. I see all my data still there. I can now issue 20 cards for an amount of 555. It still works. So now the GUI has no way of locally handling all those events. So we can go into the commands, and we see that the only node handling commands is this one, and it has received 29 commands now. Of course, for the queries, we can do the same. You can deploy them separately. We can even query our events. So if you're familiar with AxonDB, this is exactly the query screen that we had before. So this is where you can basically look into the events that you have stored in the Axon event store, including the tokens. So they are the newest events are displayed on top. You have an issue type. Of course, everything I did was issued events. So let's redeem a card of 111. So you can see it went down to 444. Let's do some more. And there's a few events. So I can now filter and say payload type. I have to pass in the whole. Almost. There you go. So now I filter out the events with a specific payload type. We can also filter out the sequence number, so we can have so you can use the pipe basically to filter some more. So we can say aggregate sequence number equals 2, and I'll only get this one. And this is a real-time view. So as soon as I pick another one and say I want to submit. Why is my UI disconnecting all the time? Submit. There's another one now that just appeared because there's a new event that passes this filter as well, and it's automatically displayed. So that means you can have a real-time view of some of the data in your event store. There's a short version of the reference guide, so just the query language reference right here if you need it. And otherwise, there's of course the reference guide online at docs.axonic.io that you can read for more information. So really, that is the stuff I have to show. I hope that you are as excited as we are about this change. We really believe that this is a decent step into making the evolution towards microservices a lot easier, and we can finally start building a more disentangled system that withstand the test of time. Yeah, if you did enjoy it, go to axonic.io/download. All the download options that you have for the different components are there. If you want to download the quick start, just use that option. And otherwise, you can individually download different components as well from Docker Hub or Maven Central if you like. So let's go